Okay, so we were talking about presenting data. I'm just going to go ahead and share my screen. Let's do that. Okay. So we spoke about collecting data last class, and now the question is, well, once you collect data, how do you present it? A lot of times we collect a lot of information, but sometimes we have to exclude data. Can you think of situations where we might have to exclude data? When would we want to exclude data?
If it's not relevant to the question, or if it's probably taking our question in another direction.
Well, yes. So if you're interviewing in the situation,
Professor,
yes,
when you talk, there is
yes.
this really loud static.
It's only when I speak?
Right. Each time you say something.
No, I can't hear it.
So
You
is
are
it
speaking normally.
okay, hold on. Let me check. Let me try without my headset. Okay.
What about now, Aretha? Are you experiencing static?
No, I'm hearing better. Are you hearing me?
Yeah, I hear you just fine. Um,
We'll
I
try.
have I have a theory as to why you have static, and my theory is that if your microphone and headset is plugged in, the cable might be just twisted or it might be frayed.
Okay.
Uh, we can try again later, but if
All
you
right.
hear me just fine, let's just go ahead and pass on the headphones for this time. So
Okay.
we might exclude data when there's withdrawal of consent, right? That's an obvious thing. Then Aretha said if the information is not relevant, 100%. If you're having an interview and you're talking about, say, responsive behaviors, and the PSW that you're interviewing starts talking about, overstaffing and the number of hours and the number of clients or residents she has to deal with, that's irrelevant information. So we would exclude that data. Okay. Other times that you might exclude data is when you have surveys or questionnaires that may not be completed. So you may have a situation where people you hand out 100 questionnaires, 100 come back, but 20 of them have only 5 questions answered, 6 questions answered. You may get rid of that. You may get rid of data when you know for a fact that the person willfully answered falsely. Somebody takes your questionnaire, and because they all get a $5 TIM card for their time, they just go ahead and check the first box and everything. Okay.
What about, oh my goodness. What about when they pick the middle row in a in a 5 or a 7 degree scale? You know what I'm saying?
I know
pick
they
the middle
pick the
one
average
that's a
response.
neutral. Yeah, that's a neutral.
Right, it's a neutral response. Now, here's the problem. You can't actually get rid of that because there's no way for you to determine whether it was their actual feeling or if they just answered neutral for everything. In those situations, because you're answering to a Likert scale, whenever you have a scale of 5 or something, what you can do is you can set up questions that test if this person is purposely answering neutral to everything. So it would be a rebalancing of scales, so to speak. And that's covered in the chapter where we look at attitudinal surveys. You can set up questions so that if people answered in the middle, you would know exactly if they were just picking the central option or if it is something that they genuinely feel for all the other questions. It's possible to do that. And there are many examples in literature. We won't get into any of those right now, but it is possible to set up your questionnaire so you avoid or you prevent people from false answering. Or you can't prevent people from false answering. You can easily catch the surveys that people have just checked off by default. So okay, this one wasn't paying attention, this one. So there are many reasons to exclude data. Should we exclude data that does not match our hypothesis?
Yes.
No.
No.
So I have one person saying yes. I have two people saying no.
Well, the purpose of the experiment is to test the hypothesis. So if it doesn't go how you thought it would go, that's just the results that you have to report, honestly, right?
Yes. So when you start picking data to match your hypothesis, that's called cherry picking your data. It's completely unethical, unfortunately, and it's wrong. You're not supposed to do it. That's why lawyers and scientists don't get along very well. Lawyers decide what the answer is and then start picking the evidence to match their answer. Okay, and that's what a lawyer is supposed to do. They're supposed to decide that their client is not guilty, and then they try to manufacture or find the evidence that supports the notion. Okay, and vice versa. So yeah, you can't pick the data to match your hypothesis because that is not proper research.
Have you heard of Stakanovites? Stakanovites, I believe it is.
What is that?
It's where they pick like a champion and they use that for their data.
Oh, I don't know about this. Could you spell that for me, Samantha?
I'm not sure. I learned about it in politics class way back in high school, and that was a long time ago.
Oh, okay. I'm gonna
Let
have
me
to
just look it up on
okay.
my phone.
Okay. Well, just interrupt me as we're moving forward, and we'll go back and discuss what perhaps we may understand from what you're discovering. Okay. So, part of collecting data, we saw an example of this table before. This is what raw data looks like. So for example, if you're trying to count the number of hours spent studying and you're trying to, correlate that to exam result, you have students, you don't put their names down, you have numbers 1 through 30. So you have 30 students, you have their raw score on the exam, 30, 25, whatever. Maybe this is an exam out of 40, I don't know. Oh, sorry, this is the number of hours. Never mind. This number of hours, there's a number of hours spent studying. So there's a whole range right from a bottom of 10. Then you have the scores on the exam, 98, 99, whatever is the score. So this is a raw table. And the challenge with this raw table is that although you have all the data, when I look at it or when you look at it, can you tell me anything about the number of hours and the score? Does that make any sense to any of you? It'll take you a while. It will eventually make sense if you spend maybe 25, 30 minutes staring at it and trying to put everything together. So this is difficult to manage. So you have a raw data sheet or a data summary sheet. We don't typically use these. We try to summarize or codify, and there's a section in your textbook talking about coding the data. So you code number of hours a certain way. AH is above average hours, BH is below average hours. So you start to create codes for the data, and you start to create codes for the score. Okay.
I have a definition here.
Oh, go ahead, Samantha.
The term Stakhanovite originated in the Soviet Union and referred to workers who modeled themselves after Alexei Stakhanov. The Stakhanovite movement was encouraged due to the idea of socialist emulation. It began in the coal industry, but later spread to many others. Basically, it says a worker in the Soviet Union who regularly surpassed production quotas and was specially honored and rewarded. And that's what they would take these Stakhanovites and they would use them as proof that this is what was happening in the industry.
Correct. And that's called cherry picking data, right?
Yeah.
Okay. We all cherry pick data all the time, and it's unfortunate because I know I don't like to dwell about the virus strategy. We're all in the virus news and COVID news because we're all in the middle of it. But I'll give you an example of cherry picked data. Okay. Italy has suffered a lot during this massive tragedy, but there was one good news story where a 102-year-old Italian woman recovered after being infected with COVID. Did any of you see that news?
I heard about a 90-something-year-old woman. So
There was
there must
there
be
was someone
another one.
there was someone 102 who recovered as well. It's on CNN. Now the fun part is a lot of older people in my family got very excited, saying, "Oh, the coronavirus doesn't doesn't necessarily hurt old people more. Look at the 102-old person recovering just fine." And then some of my Italian friends said, "Look, this is Italian resilience. Look at the 102-year-old recover. This is all because of our Italian genes and Italian food."
Mhm.
I'm thinking, this is a classic case of cherry picking data, right? You ignore the massive amount of spread and the massive amount of fatalities that this disease is causing, and you cherry pick. And that's the issue. We all like to do that. East Indians keep talking about massive examples where East Indians are very successful, and they say, well, this is the potential of our people. And I keep thinking, you know, you have a certain number of people. There will always be successful people. There will be less successful people. And this is like the Stakhanovich model that Samantha said. And it's an example of cherry picking data. Scientists don't tend to do that. Politicians absolutely do. Okay, politicians will cherry pick. Politicians will highlight their accomplishments all the time when going up for re-election while ignoring all of their failures. And that's how they try to get re-elected. Anyway, thank you for that, Samantha. So we're talking about the data itself and how to code it. So raw data, as we saw the previous slide, is very hard to interpret. So you can start to code the data. So, you know, instead of, so this is 30, 30 is average, greater than the average number of hours. So you can go ahead and put a code here. 25 is above the average number of hours. Let's say the average number of hours is 15. 10 would be below average number of hours, and so on. And the score, obviously, this is above average score. This is above average score. This is a below average score. So you can start to code these. The advantage of coding all of these is you can put all the AHs together. You can put all the BHs together. You can put so you can put the number of hours together, and you can put the number of scores together, and it lets you look at the data in a different way, in a simpler fashion. After telling you everything about coding and how coding helps you visualize data, I'm going to tell you later why I don't believe in coding. Okay, so be ready for that. All right. I don't like coding for quantitative data. This is all we're talking about representing quantitative data. And the reason I don't personally like coding when I represent my data is technology has made it so simple that you don't have to code data. You can visualize everything using an Excel sheet very, very simply. But for the purposes of this course, understand that you can code your data so that it's easier to sort things out. So the most common form of representing data, when we represent quantitative data, we represent it as a table. Tabular representation simply means you represent things as a table. And what you can do is you have a certain number above average, you have a certain number below average. And when you code everything above average and below average, you can just start to make check marks. People like to make check marks as it's shown in your textbook. I personally like the statistical method of going ticks. Then every fifth one is one across, so that means 5, 10, and so on. And then you do the same for your below average. And so your result and hours are here. So, you know, you can talk about the number of students in hours and above and below average. So you can look at the data this way. Now, this kind of a notation, or the number of checks, although people can add it up, you don't get an instant number for your data. So it's preferred that you actually have things as numbers, right? These are all examples from your textbook. So although you're starting to get your data from the initial numbers because of your code, if I give you this data, of course you can count. You'll say, well, above average is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the number of students who scored below average despite putting above average number of hours is about 7 or 11, whatever that number was. And you can get to various conclusions. Still relatively not reader friendly. It starts to get a little more friendly when you start to see numbers. Now, when data is completely tabulated in any research papers, this is the way the data looks. So we had a total of 30 students, correct? So the number of students who spent above average time studying were a total of 16. How did they score? Well, of the 16, 11 scored above average marks and 5 scored below average. The number of students who studied below average number of hours, there were a total of 14 students who studied below the average number of hours. 12 of them, perhaps as a result of studying less, got less marks, and 2 of them actually got above average marks. Now, to know that you're doing your math correctly and you've accounted for everyone, the sum of your total students needs to be 30, which is the case. And so you add them up this way or you add them up this way, they should always give you a total of 30 because that's the number of students you started with. This method where you write down the number of students for representing each type of situation and then you add them up, this is called cross-tabulation. Okay. Cross-tabulation is important because it ensures that you're adding up the number of incidents correctly. So I'll just go back one slide to indicate something I should have spoken about. The number of times anything happens. So the number of times that you have students spending above average time studying, okay, the number of anything is called a frequency. Frequency is literally the number of events, okay? So if you have a graph, and let's say number of millionaires per, let's say 100,000 people. And you have a scale of time, so 1950s, 60s, 70s, and so on. So based on what you have, perhaps you have something that looks like this, or graph. So this graph tells you the number of millionaires that came up out of every 100,000 people. And because it's representation of a number, it's called a frequency, okay? So the frequency is basically the number of incidents of anything occurring. These kinds of totals that you get when you cross-tabulate, these are called marginal totals because this is the total of a margin, okay? That's your margin. Okay. Okay. Now, you may choose to not represent. So in the previous example, we looked at absolute numbers to represent how many students spent above average time or below average time and whether they scored above average or they scored below average. Okay. A researcher may choose to also demonstrate the relationship using percentages, okay? One second, I'm sorry, I have a loose dog. I'm just gonna make sure he shows up and doesn't take off. Sorry, apologize. Sorry, my dog is back. All right. So you can also represent your data looking at the amount of times studying in terms of percentages. Instead of having absolute numbers, you can look at what percentage of 30 students spent above average time studying. You can calculate that it's about 36%, and the number of students who spent below average time studying would be about 16.7%. Okay, you can do it as percentages. Now, what is often done is you see this number when you represent data. N equals 30 means your sample size was 30, or there were actually 30 students present. Okay. You can, and N equals 30 corresponds to 100%, essentially means that when you have 30%, 30 students, that was the total number of people that you studied. You can also, instead of cross-tabulating, you can show N, which is the number. N just stands for number. So when N equals 16 means you had 16 students spend above average time. N equals 14 means you had 14 students spend above average time. So there are different ways in how you can represent your data. There is no right or wrong way, but the idea of creating a table is to make data simply understood. Now, as valuable as tables are, tables take a few seconds for us to process the results. Even if, like, I'm an experienced researcher, I can look at a table relatively quickly and see what's happening. But even though that is the case, pictures are always more valuable. That's why graphs become more important. There are many kinds of graphs that represent data. So for the same example of students studying and scoring a certain amount of mark, when you look at the number of students scoring above average in an exam and you plot it out as a graph, you see that there were 11 students who studied more than average, right? And there were 2 students who studied less than average but scored above average. So you can see that it's very clearly skewed that most students who study more score more, right? It's without, you don't have to do much work to understand it. Somebody might ask, well, what about the students who studied more but scored less? And if you wanted to incorporate that into your graph, it's basically more detail on the same graph. Everything shaded in gray is about students scoring less than average, okay? So you have a scale starting at 0, and these are all above average scores, and these are all below, students who scored below, and 0 would mean no students. So there are clearly some students who studied a lot but didn't score too much. And there are obviously the majority of students who studied less scored less as well, okay? The moment you look at this graph, you can pretty much interpret right away that if you study more, you would score more, okay? A table makes it a little more complex. A graph usually makes things more simple. Now, you might decide to ask a different question in terms of just boxing it out and not representing it as a graph. You just make it as a proportionality situation where you have boxes with a different proportion. So you can see, and this is all percentages now. So almost 70% of people who studied more got more marks, which tells someone looking at this going, well, there's an exam coming. If 70% of students who study more get more, I should probably do this. Obviously, you may want to roll the dice and say, well, 14% of students studied less and got more. Why should I study more? I might want to study less and get more marks. That way I have more time to do other things that I want to do. But at least it gives you information as to, you know, very quick and rapid information on what you might be able to do in terms of understanding what more studying means to your mark. There are other ways to represent numerical data, other types of graphs. This kind of a chart is called a pie chart. The limitations of a pie chart is that a pie chart does not say one thing versus the other. So it makes no relationship. So you cannot relate hours to marks in a pie chart. What it will do is it'll give you proportionality. So if you're looking at the number of, again, fictitious data, number of students in my class and what's the breakup. So you have 60% Canadian students, 10% British, 10% Chinese, 10% other, and 10% Filipino or Filipina students. Okay, so a pie chart is more to measure proportional representation of different things. So for example, if you want, older adults, if you want to see, you're looking at long-term care, what was their retirement income? That would also be a pie chart. And you have different sectors which represent. So it goes without saying that if you look at this graph, it's not very hard to say that even if you don't have the numbers, you can easily say that most of the students in my class are Canadian, okay? And there's a smaller proportion of everybody else. This kind of a graph is called a scatter plot. The idea of a scatter plot is if I had 30 students and I'm looking at, this is the examination result on the left, on the y-axis. On the x-axis, I have the number of hours spent studying. I could plot each student out on the graph saying student number 1, do I have student 1 here? Yes. Student number 1 spent about 30 hours studying and they scored about 98. Student number 2 spent 25 hours studying and they got a score close to 100, and so on. So I can plot each student out. Student 5 put about 65 hours, got about 65 marks, and they spent about 20 hours of studying. So this kind of a plot is called a scatter plot or a scatter diagram. This is another way to represent data. The issue with this kind of a scatter plot is if I have a scatter plot of this type and I represent all 60 students, I'm going to get dots all over the place. However, there's lots of software available. You can do it on Microsoft Excel as well. That'll plot a line through this graph to make the correlation between number of hours and number of marks. If you don't have such a software, in the old days when we did not have software, we would just have graphing sheets. We would draw our own X and Y axis. We would plot all the dots on it. If you had 30 students, we'd just plot all the dots. And then what we would have to do is we would have to, it's called modeling a line.
Does it have to be a straight line or can it be a curved line?
So what happens is when you're doing it manually, it's ideal to go with a straight line. But what happens with software is you can curve the line itself to represent the data more, and the software will do that for you. It's harder to model curves when you're manually doing it because you don't really know what's closer to the actual interpretation of the data itself. So that used to be the way, but these days it's very simple. Nope. Cassandra has entered the waiting room for this meeting. Anyway. And we'll do a little bit of that if we have time today because I have that all set up on my Excel sheet. So other than scatter plots, and this is an example of a line that's not straight. This is something that has been plotted using dots. This is trends in immigration. If we look at total number of immigrants coming into Canada between 1985 and 2015, what they've done is they've picked up the total number and they've put a dot there. They put a dot there, they put a dot for every year. And they basically play connect a dot. And then you get this kind of representation of the data. Now, when you look at this data, what can you tell me about immigration trends in Canada?
Around 1989 to 93 was high, and then it dipped, went back up in about 97, dipped again. It went to its all-time low at approximately 97, and its all-time high for that period was 2015 of 300,000.
Okay, wow. Aretha, well done. So Aretha has done a couple of different things. I was expecting a very simple answer, which would have been right too, but I like the complex answer as well. So Aretha has dissected the graph into many parts. So Aretha hasn't done this. She didn't draw any lines for you, but in her head she did. She made a linear line here. There's an increase here. Then she made a second linear line here. Then she kind of made a line this way. Okay, so she even though she didn't say it, she has seen linearity in trends. Okay, if we were to just look at the broad scale of immigration itself, if we were to plot a line, which modern software allows us to do, we'd say overall over a 30-year period, immigration is going up. Okay, shorter trends. Well, as Aretha said, it went up between this time. It went up between, went down within a certain period, and it has. Well, if you look at it overall, it's been going up and down. But if you were to draw a line using modeling software, overall it goes up. This kind of a graph is called a line graph. This is another way of representing data. The previous graph was called a scatter plot. Sorry, Courtney, did you have a comment?
What's that? No,
Okay.
I was just listening.
Okay. All right. Line graphs don't necessarily have to go in one direction, which means you don't necessarily have, line graphs can take a lot of different forms. A line doesn't necessarily mean a line. It can be a curve, as Samantha has suggested previously. It doesn't have to be a straight line. Line graphs can, when you connect the dots, they can take many forms. Line graph can go this way, it can go this way, it can go a bunch of different ways, up and down, and so on. Okay, this is an example. This is an example of a line graph where the number of hours a parent spends on housework because a child starts growing up is obviously reducing. So in this case, if you were to draw a trend line, it's a negative trend line, which just means that overall the number of hours decreases. Now, when interpreting line graphs, because you not only will you be presenting data, you'll be interpreting data too. There are things that you have to be cautious about, and this example highlights the above. Okay, take a look at both graphs, take a minute, and tell me whether you think the graphs are same or the graphs are different.
I think they're representing the same
Numbers have been spread differently.
data. Sorry, Constance.
Go ahead.
Two people for same.
I was just
I think it's the same as well.
gonna say
Yeah, it's the same. It's just
differently.
the numbers on the left-hand side are more, there's more increments in the one on the top than there is on the one on the bottom.
Mm-hmm.
So they are the same.
Excellent, thank you. And so the key thing to notice here is depending on the scale. So this, on the y-axis, you have what we know, both of them are scales. One is a time scale and one is a frequency scale. So this is frequency because number of incidents. Because the scales are different, it looks as though things move much more dramatically in this graph in terms of crime, and this graph, nothing's changed. And depending on your scale, it completely changes how you interpret the data. So even when you look at graphs or you create graphs, if you are trying to make a point about something, you have to make sure your scale reflects that. Okay, so scale is very important. We'll look at some more situations where the scale challenges how we perceive it. So you can't just look at a graph and say nothing's changed here or something's dramatically changed here. You really have to look at the scale so that you are comparing apples to apples. Another example, you have two cities, city A and city B. Okay, city budget for environment. On the face of it, it looks like city A has been increasing its budget quite dramatically, and city B really has been slacking off in spending for the environment. Until you pay attention to the fact that there are two different scales here, scale 1 and scale 2. Scale 1 is talking about city A spending money in the hundreds of thousands. So, okay, they spent 100,000, 200,000, 300,000, 400,000, 500, 600, 700, 800, 900,000. Excellent. City B, which looks like a complete slacker, has also spent close to $1 million. But the scale is different. So the slope alone doesn't tell you the complete story. Okay, so if you have a singular scale, then you know everybody is being measured against the same scale. So anyway, so the key is to pay attention to the scale while you represent your data or while you interpret other data. Often you will also see in graphs, when you look at line graphs, looking at phone call received by 3 fictitious Canadian counseling services, each service has a different representation. So one has a solid line, one has a dotted line, and one has a dashed line. And as you can see, you know, you can look at the calls received each month, and they're all directly measuring frequency, and they're all represented differently. So graph doesn't just have to have one variable represented on it. It can have multiple variables, multiple dependent variables represented. Oftentimes graphs use averages to represent something. So, you know, let's say, oops, sorry. Median income in Sudbury. And let's say 1970s, 1980s, 1990s, 2000s, 2010. Okay, yeah. Okay. My question is, don't worry so much about the graph. My question is based on why median income? Why do we worry about the median?
Because that tells us it's a balance between minimum income earners and persons who would be considered above the minimum belt.
Okay.
So we can gauge the earning of our population by, you know, how many people are closer to the poverty margin as opposed to how many people are living comfortably.
So median is just representative, right? Does anybody remember what the median is? What is a median?
You add two numbers and divide by 2.
That's the mean. Okay, so that's the mean. Okay, so let's but thank you for trying. A median is a middle value. Okay, just like on the road you have a median, it's a middle value. So if you have 10 people, if you have 10 different numbers, 10 people, your median would be right in the middle value. So there would be 5 people above it, and there would be 5 people below it. That's your median value. So if you have 100,000 people, your median value would reflect whatever it is, whether it's income, whether it is height of the individual, whatever it is, it would be the right in between value. For a long time in public consumption of data, the median has been used to represent a middle value. The reason we use averages of any kind, whether it's the mean, the median, or the mode, the reason we use these averages are, it's easier to look at averages than look at entire population. Just think about the student example. It was much easier to see, to recognize what's going on if you knew the average number of hours correlating to the average mark. okay? Rather than look at each of those individual plots. So these are all of them are averages. When we say averages, a mean is an average, a median is an average, and a mode is an average, okay? In common parlance, if you want to average something, you're talking about the mean. But to a statistician, all of them are averages. A mean is an average, median is an average, a mode is an average. There are certain situations where you cannot apply the median. There are certain situations where you cannot apply the mean, and there are certain situations where you cannot apply the mode. The mode is used in certain situations. Let's say I have a classroom of 14 students in my research methods course, okay? And each student, I'm going to, if I may label them 1 through 14, and so on up to 14, each student gets a certain amount of mark. You know, you get a lot of 80s, a couple 70s, 1 or 2 60s, some 90s, and so on. If we were to plot a graph on the distribution of marks, okay, so number of students and marks. And this is a lower mark, and towards, as I go to the right, it's a higher mark. So if my students, this is the number of students, okay? So what is this telling me? What is this graph telling me?
That most students, or that I guess many students, have a mark closer to the higher end of the scale.
Absolutely right, Cassandra. So this graph represents that my students are getting a higher mark towards the higher end of the scale. It doesn't mean there are no students getting poor marks. It just means a lot of students have got high marks. Now, if I were to take the mean in such a situation, the mean would probably land somewhere here, okay? That's not the bulk of my students. The mean might be a 79. Even though that's averaged out the entire class, if I have 14 students and 9 of them are getting 80s and 90s, shouldn't my average reflect the majority of the class, right? One second. Sorry, I had to tell my son to keep it down, but we're back. Anyway, so many students score a higher mark, and that would not be represented by the mean, because the mean would give me a lower value because the students here would be bringing down the mean or bringing down the average, correct? I can't use a median for exactly the same reason, because if I split my class up, the middle value may be somewhere here. Okay, half the students here and half the students here, and it still underrepresents what the class is doing. So in such a situation, the only correct average is the mode. There are not too many situations where you can use a mode, but there are certain situations where the mode is the absolutely correct average to pick, okay? Looking at median incomes of cities and towns, statisticians often use the median. It may or may not be correct, but it's become more of practice that they use median values. And you know, depending on the city, it may have to be changed as to what you take as a representation of the population. Anyway. So that's pretty much everything for quantitative data representation. I'll take a couple quick questions if you have anything about how you represent quantitative data, and then we'll move on to qualitative data representation. Any questions? None? Okay, let's move on to qualitative data. There are different ways to collect qualitative data. Obviously, the first one is observation. And this is from your textbook. So, you know, it's a very basic qualitative technique where you have both non-participant observation as well as participant observation. Whichever one you do, there are 3 basic foci or focuses. I like to say foci, the authors like focuses, doesn't matter. 3 general focuses of observation are common to whether you're a participant observer or a non-participant observer. Obviously, the whole situation is very important because the whole situation is context. You have to observe for that. Then, of course, you have to observe the participants themselves, okay, and observe their behaviors. So that's each individual's behavior that you're observing. And finally, we are all human beings. We have our own perceptions of what a situation is. So we have to account for that. So whenever you make a table, there has to be a section talking about the whole context. There has to be a section that addresses what the researcher observes, and then there has to be a section or a part of the table that talks about what their perceptions of the situation are. You can write your context in a different box, but for example, what we observe as researchers, let's say person A pushed B to the ground. So let's say we are recording responsive behaviors. Now your perception might be that A was getting agitated as B entered the cafeteria. Right? So, and you, as you're recording responsive behaviors, you go ahead and, code and you write down what you observe and your own thoughts as you start recording these observations. And so the way you collect information is different in qualitative data. And then what you do is, once you have all your information, you start to code that information. Oftentimes, this is what coding looks like. You code things from an interview transcript as well. And coding tends to follow certain rules. So for example, if you're talking about finding employment as a student in Sudbury, you might have a lot of data from the interviews. You may have pages and pages and pages of stuff. So for example, this is from one interview. So you start to talk about employment, looking for employment, and topics of racial discrimination as they come up. So when you start to go through your interview, there might be themes saying, it's not that the interviewee may use terms such as racial discrimination, but this is for the researcher to induce. So for example, they say, well, the moment I told them my name, they said the apartment was no longer available. Or the moment I showed up, they said it was taken. So, or they, initially got the interview for the job, but then when I showed up to work, they said, oh, the position was already, things like that. So it may come up in different parts. And so the interviewer starts to identify where those themes pop up. When you have typed up interview sheets of transcripts, what interviewers will do, like what I like to do is I like to sit with a whole bunch of colorful highlighters. So I'll have like the whole stash, whatever Staples can supply me, okay? And then I'll start to highlight different sections in different color. Anything that has, so for example, if I was doing the study, anything that has racial discrimination or the tone of it, it gets coded in a certain color. Anything that is applies because the person was female has a different color. Anything that applies because the person has a poor credit history, it takes a different color. Anything that impacts their ability to get a place because of their employment status, that has a separate color, and so on. So we start to code different things. And then so there are first broad codes. So I might decide to go ahead and highlight things that are of a racial tone. I might highlight things that are more of a social network available to the person, and so on. So you go through this coding process and you start to collect the information, and then you start a picture starts to form as you start to do this for multiple interviews. You find that, well, there's one of the things why a lot of immigrants can't get places is because of how they look, their physical appearance, or how they speak, maybe their linguistic barriers, perhaps the food that they cook is unfamiliar, and so on. So these are themes that start to come out of the interviews, okay? So this process of coding is very common in qualitative studies. The other concept that you have to recognize is while we start to code stuff and we start to understand situations or phenomena that are going on, phenomena are kind of useless without a framework to explain them. Those kinds of frameworks are called typical actions framework. For example, and most of you can see me because I have my video on, people from different cultures greet each other's different way. For example, if you're talking about Muslims greet each other by saying salam alaikum, assalamu alaikum. And I don't know what that means, but I assume it's a form of greeting, like most East Indians will say namaste with folded hands. Namaste means I respect you, I pray to you. And that's how we greet each other. So the cultural framework for a Muslim saying assalamu alaikum or for a Hindu Indian saying namaste is that fellow Hindus recognize what this person's doing. Now, if I go ahead, join my hands and say namaste to the average person in Canada, it doesn't necessarily make any sense, right? Or if I say assalamu alaikum, that doesn't make any sense either. So it's the framework is different. But in India, it wouldn't be an issue at all if you went ahead and said namaste in India to an East Indian person. Obviously, if you said namaste to an East Indian person in Canada, it may be interpreted quite differently. Okay, so the framework is very important. So these are called action frameworks. So the framework in which a certain behavior is understood. Yep, that's pretty much it, representing qualitative and quantitative data. Okay, the last thing is qualitative data often gets represented as written reports, and you don't have any graphs, you have paragraphs addressing what happened. The final thing, of course, is after you present data, you have to get into conclusions to be able to correlate what you represent with your research question. And we'll get into conclusions next and how you actually make your data accessible in your last class. Okay, so I'm going to pause now and I'm going to make time for some questions or comments that you may have. This is mostly chapters, I want to say 11 and 12, and then we have chapters 13 and 14. We should finish that by next class. On your exam, you may have one question that deals with chapter 11 and 12 and 13 and 14. I think there's a mixed question, but you only have to answer 10 out of 12. So if you're comfortable answering the question, go ahead and do it. You have other options, okay?
So Professor, our next class is this Thursday?
Correct.
Hmm.
That's the last day of classes. Is there any reason you don't think it is?
No. I'll be here.
Okay. It's going to be relatively quick class. Oh, I forgot to tell you. I was meaning to show all of you why we don't do everything by pen and paper anymore. And the reason we don't is we have this wonderful software called Excel, which has existed for almost 25 years. So probably older than some of you, but it still works and it's still useful. Okay, so I just copied this data down from the textbook, but to be able to show you how we use this data. And one of the things the textbook does is it codes different things as above average, below average. The reason we don't do that is in Excel, it's very easy. So if you look at the number of hours and you wanted to sort students by hours, all you would do is you'd go ahead, highlight this, and you would go to sort and filter, and you'd say sort smallest to largest. And if you went ahead and sorted it, magically what happens is if you look at it, it is an increasing and decreasing order, okay? So it's quite easy to see that these people studied below average. The number of students studying above average hours is right. I don't know what you want to, if you want to say 30 is the highest, so let's say 15 is the midpoint. If you want us to find out what the average is, that's also easy. All you do is click on a box and you go to this feature called auto sum and you just say average, and then it finds the mean. And then you hit that and you know your average is 22.95. So anything under 22.95, which is all of this here, is the number of students who spent below average hours. And everything here is the number of students that spent above average hours. So it's very easy to do that with existing software. That's why I'm not a big fan of coding for quantitative data. It's pretty simple to do without. So I'm just going to go back to the original graph. Now, there are many ways to plot these graphs. If you wanted to just simply plot them in a disorganized fashion, you can still do that. You can insert a chart here. And you can make a bar graph, which looks something like this. Collects both data. It recognizes them as series 1 and series 2. So the number of hours corresponding to the number of marks. Series 2 is your score, series 1 is your time. So as you can see, the number of hours spent and the number of marks is not necessarily proportional all the way through. Okay. If you wanted to figure out what the distribution in the class was regarding the number of hours studied, you're just curious to know how much did people study for this test, you can just go ahead, highlight that section, you go into insert, and you say pie chart, and you ask for a pie chart. And you have an individual representation of how many hours each person spent. You go ahead and click here. Okay. The issue is because this is raw data, what happens is it picks up everybody. So it's better to actually organize them the way we said, either in increasing order, decreasing order, and then you can average each number. And that's relatively easy to do. So for example, if we wanted to sort by hours, we would just go to the hours column and we'd go ahead and say sort smallest to largest. And it asks me if I want to expand the selection. I say yes. It does. And now what I can do is, we know the average is 22.95. So everything below 22.95, which is up to here, I can just take an average for that. So I can say, let's average this out. I go here and I say average, and I can highlight up to here. And that's the average of a number of hours for students. Let's call this students below average hours. And if I wanted to look at students studying above average hours, what's the average number of hours they studied? I can go ahead and highlight everything above a 22. And that would be students above average hours. So this is what the students on average studied who were below average hours. Now the scores themselves, so we can resort by score now, but because we have it distributed that way, what did the students who studied below average hours, what did they get for scores? We have this number here and we can average that out too. So if you wanted to look at what their score looked like, we go back to average and we pick up everything up to that and we say, well, they scored an average of 75%. What about the students who spent above average hours studying? So let's go ahead and let's make an average here. Oh, sorry. Undo that because that's not the box where I wanted it. Okay, there we go. Interestingly, students studying above average hours got a lower average score of 63.63. For this particular exam, it's better you study less. That's what happens when you make up data. You don't get the results that you expect to get. But you can see how easy it is to do all of this work instead of coding, sorting, because the software and the databases we have out there make life very, very simple. You don't have to just do above average, below average. You can also say under 20 hours, so then you'd have just these four. 20 to 30 or 21, 20 and below would be here, 21 to 30 would be here, and then 30 and above would be here, and so on. So you can sort them out many different ways. You can get the average score for each person, and it's quite simple. Now, just how many of you have used Excel to make data sheets or graphs?
I think I've used it a little bit, but
Yeah.
not for making too many graphs. Like I've used it for other data collection means.
Okay. It's a relatively simple tool because there are lots of complex software out there. You don't have to have Microsoft Excel. There are equivalent software available. Google has its Google Sheets, I think. I can't remember. Perhaps it's Google Sheets, which lets you do the same thing. OpenOffice has that as well. So there are a lot of different software which replicate what Microsoft Excel can do. Okay. I'm done from my side for today. We have 15 minutes more. Do you have questions or concerns or anything that we need addressed in this class?
I just want to say sorry for being late. I literally forgot what day it was until I checked my email and then saw the link in there.
It's okay. It's okay.
I
Well,
thought,
the
oh
good
my
thing
gosh,
is,
my lecture started 30 minutes.
yeah. Well, it's easy to lose track of time. We're all, most of us, I believe, are homebound. I know a couple of students who are out there and working in the field. So just stay safe for those of you who are working outside of home, and those at home, make sure that your entire family isn't going grocery shopping. Perhaps just one person in the store.
Just
Keep
me.
yourself safe.
Professor, Thursday, I don't know what happened. I literally lost track of the day. When you get up in the mornings and you look outside, do you realize it looks like a holiday every day?
Correct.
And sometimes when it's overcast, it's just depressing.
So that's my excuse when I don't show up this Thursday, okay?
It's not an excuse, but it's the truth.
Oh, I'm kidding. I will be there on Thursday, and I hope all of you are. It's sometimes it's hard. You don't know how a joke is being received over the internet. Well, fortunately, you can see my face, so you know I'm smiling. I'm kidding, right? So we will have a last class.
The situation, it does get to you.
It does. I'm trying a new thing which I think will help me. I don't know if it'll help you guys, because it's so depressing and there's so much gloom and doom. I find that if I start to read stuff right in the morning, it messes up my productivity. It impacts my ability to do things well throughout the day. So I've dedicated all news reading at the moment to after 3 p.m. And I have not been disciplined, I'll be honest. I tried it on Friday. It worked really well. Then on Saturday, I was indisciplined and I read it first in the morning as I woke up, which was horrible. And it just makes you more addicted to spend time with the phone and the news, and
Yes.
And we can't do anything about it. So, I'm going to try again today. Today is start again. Well, you fall off the wagon and you try again. Right?
Get back on.
Back on. So I'm going to try to not see or pay attention to any news till about 3 p.m. And by 3 p.m., if I've been working, I'm usually quite exhausted anyway. And at that point, I'm not being productive. So I can look at all the garbage stuff that's out there and all the negative news. That's how I think about it.
I've been reminding myself of this quote I saw that says, where focus goes, energy flows.
100%.
So I've been focusing. I started last week, same thing as you, focusing on the news, social media, what's going
Yes.
on. And then I found it impossible to do any schoolwork at all.
Yeah.
You know, so if you refocus, then hopefully your energy will follow your focus, but
Yes.
you have to manually be like, no, I'm not
Yeah.
looking at that. I'm looking at this.
Yeah.
We have to practice what we tell our children, right? That's enough of that. Go do your work, you know?
Yeah.
So
Yeah. Yeah.
anyway, I just pretend my mom is here with me and she's yelling at me, go study.
That's a good strategy.
Yep. That's what my mom always used to tell me, you know, go study. Your friends are no good. So at this point, it might work. All right. Well, thank you, everybody. And we will have our last class on April 2nd. Now, I have a request for all of you. We aren't able to get any feedback regarding the course and its presentation and any feedback for myself because everything is by distance. There's just no practical way to do it. And I would like feedback from you guys, but I want it to be anonymous. So I don't know how we do that. Obviously, I don't want emails regarding the course because that compromises your anonymity. But if there is a site called Rate My Professor, it's very informal. You don't have to rate the course or anything now, but maybe sometime in the summer, maybe June or July, just go over if you can to the website and whatever you feel about the course. I have no issues having a brick thrown at me. I have no issues with that. Go ahead, you know, suggest improvements for the course. Obviously, it's better if you're kinder just because it won't hurt my feelings. But
Okay.
but I'm a big boy. So if you need to say that these are the things I did not like, I'm okay with that. But if you have improvements, suggestions for improvement, that would be even better. So go ahead and if you can, if all of you can, and it's anonymous. I've never seen a name on that site. I often, you know, I don't use that as a source of information because it's not valid, but some feedback is better than no feedback is what I think. So sometime in the summer, once, you know, you're free of this course, you have some time to think about things, please go ahead if you can. And you know, I don't know what the protocol is to put stuff up, but I don't believe you have to create an account or anything. I think you can just go up and rate or whatever, and you can make comments on the course itself. So please go ahead and do that. I would appreciate the feedback personally. Okay?
Okay.
All right.
Professor, I don't know if you'd mentioned this at any time or even last week or if anybody asked, but so we have this social distancing and graduation should have been on June 2. Chances are it may not happen, but have you heard anything?
I will guarantee you that it's not happening.
Yeah, I figure.
And it's to keep everybody safe. And I hate for that to be the case. I just don't see how it can be done safely.
No, it's okay.
That's why.
I was just
Now,
checking.
obviously, I don't represent the university. The university has not canceled anything. So this is Krishnan telling his students. This is not Laurentian telling you anything is canceled. So not to be construed that way. Okay, so it's just my opinion that unfortunately it's
not looking that way.
It's not looking that way.
Okay? I have been getting some emails from the graduation.
Okay.
In area, I don't know what you call them. If you've, I don't know if you can hear me. It says my internet connection is unstable.
Yeah, you're breaking up.
You froze for a second. Your face was frozen, but now not anymore. Well, there you go.
I was just going to say they're sending out emails. I got one from graduation.
Okay.
Graduation at Laurentian. So if you've applied for graduation, you should be getting an email. They asked you to update your address because they're going to mail you your diploma likely.
Yeah. I you know what? Unfortunately, that's how it's going to happen. I enjoy going to graduation and meeting my students there, but
I look forward to walking across the stage after all this hard work.
I know. You deserve a good graduation. And what they have said is they're not canceling the walking across the stage. They're saying, because there are 2 graduations at Laurentian, one in spring and one in fall. There's one in October. So they might still have you walk across the stage and receive a paper roll, not your actual degree, but they might do it in October. Have everybody come in and do it if it's if it's safe at that point in time.
All right.
And that's not uncommon. That does happen if there are some calamitous situations like this one.
Okay.
Okay.
Thank you, Kristen.
Thanks. Take care. Bye-bye.
Okay, Professor. Bye.
Bye-bye. Bye, everybody.